Fine. Good morning, and once again, welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamotho. And in this video, we will continue to explain pure mathematics 1 and topic number 6, trigonometric ratios. But specifically, we'll be looking at example 13 that talks about transforming trigonometric graphs, and you'll find that on page 126. And in this video, I want us to just see how we can remind ourselves about Mayo and the transformation of known graphs to resulting curves, and let's see what happens. In part A, we are supposed to sketch y is equals to -1 plus sine x from the range of 0 all the way to 360 degrees. And for this, we know if you look at this kind of function, it must have been generated from the function of y is equals to sine x. This is the function that has been transformed to this. So let us first of all understand what kind of curve did we originally have. So in this curve, this is the known curve of y is equals to sine x when x is 0 or y is 0. When x is 90, sine 90 is 1. When x is 180, 0, 270, of course, minus 1. And when x is 360 degrees, then we have y equals to 0. Now, this is the graph of y is equal to sine x. So, but according to Mayo, our magic square of transformation, this is addition outside. Outside means it doesn't affect the x anywhere. So addition outside means vertical translation. It means vertical translation of a steps, and our a is simply -1. You can see it. So vertical translation of -1 step. What does this mean? All y values, you subtract 1 step. This means now all y values minus 1. Let us now see what kind of transformation that will be born from there. When x is 90 degrees, 180 degrees, 270 degrees, and 360 degrees. All y values minus 1. So what does, not minus 1, is it really? All y values not minus 1. Our a is minus 1. Yes, our a is minus 1. And all vertical values, vertical translation of -1 means all y values you minus 1. And that is just like what is supposed to be. That is what it's supposed to be. So when x was 0, then 0 minus 1 becomes -1. So this point comes there. When x was 1, when x was 90, y was 1, 1 minus 0, 1 minus 1 becomes 0. When x was 180, y was 0, 0 minus 1, it becomes -1. When x was 270, y was minus 1, minus 1 minus 1 becomes -2, becomes now -2. So when x was 360, y was 0, and 0 minus 1 becomes -1. And that is just what we can talk about in such kind of a graph. So we have something like this. We have something like this. We have a graph that looks like that. And this is the graph of y is equals to 1, or rather -1, -1 plus the sign of x. And as you can see, it has been summarized by the Mayo here, whereby we got addition outside, vertical translation of A steps, and our A was -1. That means all Y values minus 1 step, and we got that graph. Let's get to part B of the question. We are looking at y is equals to a half plus the cosine of x. From what is the range? From 0 all the way to 360 degrees. And this one is generated from the general graph of y is equals to. This one is generated from the general graph of y is equals to cosine of x. And let's just have it here. Y is equals to cosine of x. And we know that when x is 0, then cos 0 is 1. When x is 90, cos 90 is 0. When x is 180, cosine 180 is simply, this is 1, this is -1. And when x is 270, the cosine of 270 degrees is 270 is 0. When x is 360, the cosine of 360 is 1. So the general graph of y is equals to the cosine of theta looks like that. This is the graph of y is equals to the cosine of x. Now when we visit now the Mayo, there is addition inside also. This is addition inside. It means not inside but outside, addition outside. Please remember it does not affect the x anywhere. It is addition outside. Please make that correction. And addition outside, this talks about vertical translation of a half step, because our A is a half. And what does this mean? All y values plus a half. All y values plus a half. So what kind of graph do we have? What kind of a graph do we have now as far as this question is concerned? I'm looking at it like I would want to plot it in the same set of axes, but the question talks about on separate set of axes. So let's do it over here, and let's make it a little longer because it's going to demand more space. X values don't change, so that remains 90, that remains 180 degrees, that remains 270 degrees, and this remains 360 degrees. When x was 1 originally, 1, and this is -1. When x was 0, y was 1, but all y values plus a half is going to be there. This is 0.1 and a half. When x was 90, y was 0. 0 plus a half is going to be a half. That is it. When x was 180, when x was 180, y was -1. -1 plus a half is going to be negative a half. It's just going to be negative a half. And when x was 270, y was 0. 0 plus a half is a half. When x was 60, y was 1. You can see 1 plus a half is simply going to be 1.5. So we look at now this graph that appears to look like this, and that is it. So this is the graph now of y is equals to a half plus the cosine of x. A half plus the cosine of x. Fine, we have finished our task as far as example 13 is concerned. We've been able to transform those graphs, and since there are no other instructions, then we can only say that that is the end of it. But I would want us to talk about the graph of y is equals to cos h is transformed by half units in the positive y direction. This one has gone up a half steps. This one has gone down one step. And that is it. All this, you'll find it summarized by the magic table of Mayo. And again, visit my YouTube channel, Pearson Edexcel International Maths by Mr. Kamotho, and subscribe. And of course, share widely and follow me. All right?